Hi, I'm Miss Carpenter and this is Humble Math. What's in the box today? Let's see. Aha, the socks in the box today. Oh, interesting. There's still the polar bear on a sled, but today he's joined by some French fries. The potato is still there, getting a little softer. And we've got a basketball. Now we've talked about spherical things, we've talked about circles a little bit, we've talked about DIY math at home, we've talked about making mistakes and how this is humble pie because it's humble math, it's very simple. We're here to make mistakes, have some fun, learn some stuff. Okay, so let's get started. So we just started to talk about lines, like you might find French fries are lines, some of them. So today we're going to keep going with René Descartes. René Descartes, he had the Cartesian plane. This is how you can find things on a Cartesian plane. So first of all, let's talk about some ordered pairs. What is an ordered pair? Well, in math, when you have brackets that look like this, they are nice round brackets. That means the order is important. If you have curly brackets like this, the order isn't important. We're still talking about a set of something, but here the order is not important. Here it is important. Well, we're going to go with the important order for now. So René was sitting around talking math and philosophy, and he decided, well, when we're trying to figure out where something is on this Cartesian plane, which is a great game, by the way, how we do it should make sense. So let's say that we're going to do it in alphabetical order. So what comes first, X or Y? Obviously X does. So he always puts X first, and we'll remember that X for xylophone is horizontal, and Y for yo-yo is up and down. Ooh, that's not getting better. So X and Y, ordered pairs. Let's start with an ordered pair where on the x-axis, we'll start at the origin. This is called the origin. So we will originate at the origin. And then let's go along the x-axis, not at all. Let's stay right here at 0. So our first ordered pair, X is going to be 0, and Y, let's go up to 1. So we went over not at all and up to 1. Okay, so our first real point is going to be right here at 0, 1. Awesome. Okay, what's our next point? Well, our next point is going to be right here. So we're going to start with X because X comes first in the alphabet. How far did I go over on X? I walked over 1, and then I went up 1, 2. So X is 1, and Y is 2 right here. 1, 2. Now I say to my students, you don't go up in the elevator until you walk to the elevator. So if you can imagine, starting here, you walk over to the elevator, and then you go up. That's one way to think of it. Our next ordered pair, let's do it the opposite way. This time our ordered pair is going to be 2, 3. So pause for a second and think, where would 2, 3 be? Well, we're going to walk over on the x-axis to 2, and then we're going to go up 3 floors in the elevator. 2, 3. Now, we're not perfect, but we're doing our best here, right? Okay, our next ordered pair, let's say we go over here to 4, 4. Now remember, mistakes, good for your brain. Struggle, good for your brain. I'm noticing a pattern here. 0, 1, 2. Here I see 1, 2, 3. 4, 4. If that's our next ordered pair. 0, 1, 2, 4. That doesn't make sense. That's a break in our pattern. That is a flag. Okay, let's stop. Let's look again. Each time I'm going over 1. This time I accidentally skipped and went over 2. So I have to rethink that. And we're trying to make a straight line. If I did that, I would no longer have a straight line. It would be going like this, and then suddenly it would veer over to the right. So let's look again. 3, 4, that makes sense. See how I'm making a straight line? In fact, right now, I'm going to take since I don't have my meter stick at home, I'm just going to take this and I'm going to make my straight line. And it would keep going. Or maybe that's all the values I have. If that is where I end, then what's my last point? Well, without even looking here, without even doing any calculations, we can use patterns to figure it out. 0, 1, 2, 3. Well, the next one here for x must be 4, and 1, 2, 3, 4, the next for y must be 5. That makes sense. That's patterns. Math is patterns. There's our straight line. Now, something really important. Remember this weird y equals mx plus b? Well, in this is a b at the very end. And b, we're going to say, stands for begin. And we're going to think about, why do we begin here? So remember, why do we begin here? B for begin. Well, where did we begin our line on the y? Because I'm saying y. Let's look at the y-axis. What is the point that's actually on the y-axis? It's right here. So I'm going to put a circle around it in red. That is going to be B for begin. And in our y equals mx plus b formula, I don't like memorizing things. So we're going to write that down every time. Don't worry. This B for begin is the point where we begin at the y-axis. So what was that ordered pair again? That was 0, 1. And the 0 was x and the 1 was y. So whenever you see x being 0, you know it has to cross this y line. Because x, if it's here, is 1. If it's over here, it's 7. If it's over here, it's -5. There's only one place that x is 0, and that's right there. Actually, that's a mistake. X is also 0 here, 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 anywhere on the y-axis. X is 0. Okay, so what do we call that? Because we always like to use names in math to help us remember things and be able to communicate with other people about what we're talking about. So, if you can imagine this ball, and my dog likes to catch a ball. So if I go like this and fail, let's try that again. If I go like this and he jumps in right there, what do we call that? Well, in football, we would call that an interception. I didn't have a football at home, except somewhere deep in the garage. So I decided to use my dog's basketball. So when you intercept the y-axis, right here with your line. So see how I'm breaking the y-axis? I'm intercepting it. Well, we're going to call that, wait for it, the y-intercept. So what do you think it is when the line, if it kept going this way, my line got a little crooked there, but and it goes now through the x-axis over here, first of all, what do you think that might be called? You got it. The x-intercept. We mathematicians are nothing if not logical, so that makes sense. Now, in French, it sounds a little bit different. We talk about abscisse and ordonnée, but that's okay. Okay, so it intercepts the y-axis here, and it intercepts the x-axis here. Well, notice what's really interesting. Whenever a line goes through the y-axis, we said the x will be 0. So what do you think happens when you go through the x-axis? So if I go through the x-axis here, what's y? It's 0. If my line had gone through right here, what's y right here? Well, what floor am I on? I'm on the original floor. I didn't go up to 1 or 2. I didn't go down. I stayed right on that main floor. So that means 0. So right here, my x-intercept for our original line that we were talking about, our x-intercept, we've got y is 0 and x is -1. I'm going to write that under where I say x-intercept. So would it be correct to go like this? Is that right? Is x -1? Is y 0 here? Or is it the other way around? What I love to do with my students all the time is make it sound like they've made a mistake or I've made a mistake, when really it was right. This is absolutely correct. X is -1, y is 0 right here, and that's the x-intercept. Those two simple concepts are going to be so important later in math, and they will help you navigate the Cartesian plane really well. Till next time.